You don't have a password for it?
Well, I have the AM and then, and I reset the top because I went to the tech guy up and I got. I said, okay.
Oh, you gotta put the password underneath it. So then write your write this password underneath. See if it likes it.
Thank you. My friend was calling. I was like, go for it. And he was, yeah, that's because I was remembering the password.
So yeah, that'll be your comment ID or your username, and then that will be your password. So I just have to log in. Yes. It happens again. Good evening, good to see you guys tonight. We got another 4 minutes or so before class will all the way officially start, but you guys can go ahead and get settled in. Please try to get on Canvas if you're able, Hydro. Because we're gonna work from Canvas tonight, so hopefully you guys have a good device. But we will wait another couple minutes, till class officially starts all the way, and then I will talk at you guys.
What's the login for the computers?
So do you know your CCC username? It should be like TI something. Like on your
Oh, for this.
student ID? Yeah, so this should work with your CCC login.
Oh, okay,
So do you remember that?
yeah.
Yeah, TI something. So the first two are always your first and last initials.
Then I just put in my password.
Yeah, do you remember it or do you have it for CCC?
Yeah.
Okay. Oh, that's funny. It's almost like a little word I got numbers and rings. No, this is. All right. No biggie. So, the reason why I'm kind of starting with this fraction review is because the unit that we're going to start, probably more so on Wednesday night. We'll see if we can, well, we might get started on it tonight, actually. Is very heavily based on using fractions and kind of the rules and things we can do. Let's say using and manipulating fractions, and manipulating is of course kind of the mathy part of math, right? Where we know certain things are true of fractions and therefore we can kind of do some specific things. So we want to go through our fraction skills just so that we're ready for this. So like I said, I think everyone got the first question, which is very good. And then maybe it didn't go super well after that, but it's okay. And once again, it might be my fault because oftentimes I make these Google quizzes, I mess up the answers, but I felt really good about them today. But here, if we start with question number 1, a yard contains 36 inches. 21 inches is what fraction of a yard? So we want to create a fraction that has the same units, right? We have to have inches with inches. And so if 1 yard equals 36 inches, 21 inches is the same as 21/36 of a yard. And so this is our part, right? The 21 inches. And 1 yard or 36 inches is our whole. And so our part, our numerator goes on top and our denominator is 36. So I think everyone felt okay about this problem. Are there any questions or confusion about this very kind of initial piece? Okay, good. And so when we create a fraction, we're showing a relationship of some part to some whole, okay? Our part goes on top, our whole goes on bottom, okay? All right, so this problem seemed to have kind of stumped people. And so it says which fractions below, and maybe that was the confusing part with my wording, but which of the fractions below is less than 1/2? Okay. And so one of the things that we learned over the summer when we focused in on fractions is there's kind of a way to assess the size of a fraction, and we're either relating it to it being less than 1/2 or greater than 1/2. And kind of putting them in those two categories. So are there any fractions on this list that are values less than 1/2? So is 3/6 less than 1/2, greater than 1/2, equal to 1/2?
Equal.
Equal, so it's not less than equal. How about 7/15? Is that less than 1/2?
Less, yeah.
Yes. How do we know that?
So if you were to like multiply 7 by 2, it's
Uh-huh.
14,
Okay.
the like whole fraction's 15. So
Good. Perfect. And so that's one of the things that we talked about, right? And so we look at the relationship between our numerator, our top number, and our denominator. And if our numerator is less than half of the denominator, then this fraction represents a value less than 1/2. So very nice, Lauren. Good. So if you can remember that rule, right, besides 7/15, what are our other fractions less than 1/2 on this list? Or are there any others besides 7/15?
4 nines.
4 9s, good.
7/16,
7/16, good.
5/12.
And 5/12, good. And these numbers here, right, are just barely less than half, right? So pretty close to 1/2, but still less than 1/2, okay? 5/8 is greater than 1/2. And then, right, 6/12 and 3/6 are all equal to 1/2. So one of the key things that we'll need to know or remember about fractions, right, is that they have many equivalent forms. So we can change the form of the fraction, but it will always be equal. So 3/6 is equal to 1/2. Okay, those are what we would call equivalent fractions. Same with 6/12. Okay, it's an equivalent value to 1/2, but it's just a different way of thinking about the concept of a half. But it's an equivalent value. So hopefully that feels good for everyone. So good job there. Hopefully you can kind of remember that rule, because sometimes just trying to, kind of look at your fraction and kind of have a sense of where is it? How close is it to 1 or 0 or 1/2? So we kind of know what amount we're dealing with. Okay. All right. Which of the fractions below is in the lowest term, or we could say simplified? So if we have 18/32, what is the lowest terms that we could reduce that fraction down to?
Divided by half,
Okay.
and then get 9/16, and that was the lowest form I could get.
Good. Good. So yes, so we have lots of equivalent fractions, but generally when we work with fractions, we want to look at kind of our answer and ask ourselves, is this the lowest terms or the most simplified version of this fraction? And so 18/32 is not lowest terms. We can simplify it by dividing 2 from the top and the bottom to get the lowest terms, which is 9/16. Does everyone feel pretty confident when we talk about simplifying, reducing lowest terms of fractions? Does that feel familiar and comfortable, or is anyone feeling confused? It's okay if you are, but because this is really important. Good. So, like I said, whenever you kind of think you're at the end of your fraction answer, you want to look and say, is there something I can evenly divide out of the top and the bottom of this fraction to make it more simplified, which just means generally smaller numbers to deal with, which makes our lives easier. And so like Soren said, we can divide a 2 out of here and a 2 out of here. And we have to, right, be able to divide out the same value from the top and the bottom, because basically when we when we find an equivalent fraction, either larger or smaller than the fraction we're originally working with, that's how we change to a different equivalent form. We multiply by a number evenly on top and bottom. 2/2 is the same as 1. And so hopefully everyone agrees. Anything times 1 is itself. So if I multiply this, or here I'm dividing, same idea. Maybe different direction, similar operation in anyway. Then I'm not affecting the value, I'm just finding a different equivalent form. And so hopefully that makes sense. And so if I divided 2 out of the top and the bottom, I get 9/16. Now when I look here, there's no whole number that I can easily divide out of 9 and 6. Except for 1, which of course doesn't affect it. So that tells us that this is, right, the most simplified form of this fraction. Okay, so this is going to be an important skill that we're going to be using a lot. So hopefully everyone is feeling pretty confident about reducing fractions, finding their lowest terms, and recognizing when you have simplified it. Because usually, right, if this is kind of like your final like calculated answer, you still have that step. So you might not see your final answer. It probably means you need to reduce your fraction. And so, yes. All right. Everyone feel good about this? Do you feel like you can do that? Makes sense? Okay.
Yes.
Good. We're going to be doing a lot of that. So I wanted to make sure that everyone felt good. Okay. Okay, so here we're kind of going the opposite way. So, oh no, wait, sorry. Here we have something. Wow, sorry. Forgot I was still on my arrow there. Look, Aaron, can you? Oh, I skipped one. Wait. Did I skip? Oh no, okay. I did skip one. Okay, so here, change 3/4 into 12ths. So here, sorry guys. Okay, move the screen and then I'll get back into the swing of things, I promise. Okay, there we go. Okay, pencil. So change 3/4 into 12ths. So once again, right, most of our denominator or like bottom numbers are going to have this like TH ending to signal that it's down here. And so what do we need to do to find an equivalent fraction to 3/4, but instead of fourths as my whole, right, dividing into 4, I'm dividing into 12. So how would I figure out what the equivalent fraction is here? Or does anyone know what the equivalent fraction is?
9.
9? How'd you get 9?
I just found 3 times 3 and 3 times 4.
Good. And so basically, right, we have 3 known values and 1 unknown value. And so you look at kind of the 2 shared pieces and it's like, what did I do to my 4 to get to 12? I multiplied it, or I think multiplying and dividing here, don't think adding and subtracting. So since I multiplied by 3 to get to 12 there. I can just do the same up here, and then 3 times 3 is 9. So beautiful job, Alyssa. So, right, 3/4 and 9/12 is the same. They are equivalent fractions, just two ways of thinking about them, okay? But it's still the same amount, right? Okay. Definitely stop me, let me know if you have questions. All right. Next. Okay, adding fractions, and I didn't notice how we did on this, but does anyone know how to add these fractions? Can we just start doing adding?
No, you have to find a common denominator.
Great, thank you, Victoria. And so we have to start with our denominators. They have to match. And so once again, we have to potentially have to find 1 or 2 equivalent forms of our fractions so that the denominators are the same. We cannot do any adding until there is a common denominator. Fortunately, between 4 and 8, what is our common denominator?
8.
8. Good. And so sometimes we don't have to change it. So our 1/8 is fine, but we'll need to convert our 3/4 into 8. So how many 8s do we need here? If I go from 4, what did I do to the 4 to get 8? I multiplied it by 2, so I should do the same on top. 3 times 2 is 6. Okay, now I have a common denominator. And I can do my adding, okay? And spell, the thing is not English. That's right. So once you have found your common denominator by finding, right, these equivalent forms with the same denominator, it's gonna stay the same. And then you just add your numerator. 6 plus 1 is 7. So 3/4 plus 1/8 is 7/8. Okay, and that is as simplified as it can be. I can't reduce it. It's in lowest terms. And so the key here is a common denominator, and I just wanted us to practice that because once again, finding these equivalent forms is going to be kind of the crux of what we're going to look into here. So, okay. Hopefully everyone's doing good. So the same thing applies when we subtract. So we look at our two fractions, they do not have a common denominator, so that's going to be my first step. What is the lowest common denominator between 10 and 5? It's kind of similar to the adding one.
10.
Good. So we don't have to worry about our 7/10. Okay. And then once again, what did I do to the 5 to make it 10? I multiplied it by 2, so I do the same up here. Okay, now I have my common denominator again. And so my denominator stays the same, and I just subtract my numerator. 6 minus 7 is 1. So 7/10 minus 3/5 is 1/10. Okay, 1/10 is reduced as possible. Often, right, any fraction that where 1 is the numerator, you can't really reduce it any more than that, right? Because the only multiple of 1 is 1. So hopefully that was good. Very nice. I feel like I did. Did I skip a couple questions? Anyway. So here multiplying into well, multiplying fractions is easier because we don't have to do all that common denominator stuff that we were doing with adding and subtracting. And so this is kind of one time where multiplication might be a little bit easier, but when you multiply fractions, you just multiply the numerators and the denominators and they just kind of stay there. So 5 times 4 is 20, 9 times 7 is 63. Then we have to look at our answer. Can we reduce 20 63rds? No. Okay. Oftentimes the bigger fractions, generally there's something, but if you have an even and an odd number, that's generally the combination you see where it's harder to, divide stuff out. Now, if there was like a 9 or a 7 or something, because 63 is a multiple of 9, it's a multiple of 3, but yep, that's as reduced as it's gonna get. So hopefully you guys remember and feel good about multiplying fractions, not too hard. All right. All right. I think I did 60. All right. Dividing is almost similar to multiplying. There's just one step that you have to do before you start kind of doing the calculating part. So when you divide fractions, you take your second fraction in the problem and take what we call the reciprocal, which means that we switch the numerator and the denominator. I switch the position of the two. And then when I do that, my division sign becomes a multiplication sign. So does everyone see the setup here? So I say, okay, we're dividing fractions. I take my second fraction. I take the reciprocal by, switching the position of the numerator and the denominator. So 7/12 becomes 12/7. Then I can now multiply, and then our multiplying works just the same. Now, there's one additional thing you can do when you're multiplying fractions or dividing once you get to the multiplying step of it, is you can look, and this is just kind of, do you want to reduce before or after? Sometimes it's easier to reduce before, and so rather than looking at the top and the bottom of your fraction, you're going to look on the diagonals. And so once again, I'm going to look and say, is there something that I can divide out of one of these pairs of numbers? 8 and 7 don't really share a lot, but 15 and 12. Does anyone know what common multiple, what could I evenly divide out of 15 and evenly divide out of 12? 3. Good. So I can divide by 3. 15 divided by 3 is 5. The same thing up here. 4. So this is called cross reducing. And once again, it's just a matter of, do you want to reduce before or after? And generally, if you reduce before, it's a little easier to get to simplest form. And so now I'm going to take 8 times 4 is 32. 5 times 7 is 35. 32 35ths, okay, is the answer there. It's as reduced as it can be, but definitely this idea of using the reciprocal to do your dividing is important, and then this cross reducing step. Okay, if we didn't cross reduce, we could still do the problem. 8 times 12 is 96. And then 15 times 7 is 105. Does that sound good? let me, I'm like, I don't feel confident. 15. And 7. Oh, I got it. So now we have 96 over 105, which is once again pretty hard to figure out how to reduce it. I wouldn't even know the common multiple must be like 3. 96 divided by 3. Oh yeah. So the only way that I knew it was 3 was because I'm super smart. Well, hopefully you guys would agree that it's a lot easier to do your reducing with smaller numbers than bigger numbers, but luckily as well, your calculator would also do this. Okay. All right. I think I skipped 2 questions or I deleted them on accident, so let me go back and make sure that the other 2 questions I was thinking are here. All right, hopefully you guys are getting the stuff written down. Oh. Guess I just moved it on accident. But we also have this idea of improper fractions. And, I don't think we'll have to worry too much about mixed numbers and improper fractions for what we're gonna focus on. But if you have what we call here, this is what we call a mixed number. A mixed number means we have, right, a whole number and a fraction. So we're representing, right, we have 11 whole and then 5/8 also, 11 and 5/8, okay? And so there's 2 ways of representing a mixed number. You can represent it as a mixed number with your wholes and your fraction reduced as much as possible, or you can create what we call an improper fraction. And so you take your denominator, multiply it by the whole. So 8 times 11 is 88. 88 plus 5 is 93. And then keep your denominator. Okay, so whatever denominator you had, you keep it. So this is the improper fraction. And it's improper because, right, our numerator is greater than our denominator. And so depending on what we're doing, sometimes we want to use the mixed number version, sometimes we want to use the improper fraction. And so when we see, especially when you see an improper fraction, your numerator is larger or greater than your denominator. All that's telling us is that this is representing a value greater than 1, right? When we have our proper fractions, we're talking about numbers between 0 and 1. And so an improper fraction is going to be more than 1 and have a combination of whole numbers and fraction. Okay. All right. Sorry that got jumbled up in my craziness here. Are there any lingering questions about what we've reviewed as far as fractions? Is everyone feeling good? Are there any questions? If you feel like you need more practice with these kind of foundational things that we just worked on, let me know. Because I can always give you guys more practice. Everyone's feeling okay? All right.
Yeah.
Cool. Okay. Whoopsie. Okay. So, I went ahead and kind of put together 4 units that we're gonna hopefully work through this fall. Probably not this quarter, but hopefully we can get through it by December, okay? And these are very important math concepts you'll see it not only in GED math, but also science and social studies use these as well. So hopefully it'll have that kind of dual, multiple applications. So the first unit that we're gonna focus on is ratio and proportion, okay? Now, for my in-person students, I made a packet with all of our math units so that you can have a hopefully easy and portable way of having your math materials. If if you are a Zoom student and you would like one of these packets, you can send me a message on Remind or even on Zoom right now, you can send me an email. And I can try to mail it to you if you're not in Flagstaff. If you are in Flagstaff or gonna be around, you can definitely come to 4th Street campus and get a copy for yourself as well, okay? And so the full packet is here, but today we're just gonna start with unit 1. So if you don't want to open the big, huge, the big, huge PDF with everything, you can also just open just the unit there. So, all right. So for you guys who are in person, please don't lose this. Hold on to it. Bring it to class every Monday and Wednesday. Okay. If you lose it, of course, you know, not the end of the world, but try not to make our printing costs too high. Okay. So if you just left it at home for a day, you know, just let me know and I can just print off the pages for the day. And then hopefully you'll remember to bring it back. If you feel like you completely lost it, then we'll figure something out. So like I said, for you folks on Zoom, if you want a physical copy of our math, kind of our textbook for the fall, let me know and I can hopefully try and get a copy in your hands. Okay, so we're going to start by looking at the concept of ratio and proportion, and hopefully you guys will, okay, thanks Art. I will, hopefully the mailing address on your registration form is correct. And there's also, if you are able to, you could go to Page Campus because I did send like 5 of them up there. So they might have one if you have it, if you're up there and can swing by the campus. If you just ask Patrice, she'd probably know. But otherwise I'll mail you one. Okay. All right, so let's go ahead and dive into our lesson. And like I said, we'll basically be kind of warming up every day, but then also working, you know, little by little through our units and our lessons, and hopefully okay. Let me know tomorrow, like if you were able to get one, and if not, I'll definitely find you one. But I'm pretty sure they got up there as far as I heard. So so I appreciate you helping me get the steaming on that. And so yeah, if you guys are closer to Page, like if you guys on Zoom are closer to Page than here, you could potentially go by a Page Campus and get your materials printed out if that's helpful. All right, so we're gonna look at ratios, and as you can see, ratios are gonna look very similar to fractions. And so ratio is kind of, well, a fraction is one way and probably the most common way that we represent ratios, okay? And so if we look here, we just think about our fraction language. Sorry. If we ask you, right, to create a fraction representing the shaded boxes, right, to the whole, right, you can see that there's 3 parts and, right, the whole is divided into 10. And so we would probably use the fraction 3/10 to represent kind of what we're seeing here in this very simple rectangle, okay? So what we're going to kind of do is use fractions and use the idea of fractions to create what we call ratios. I'm sorry if I'm repeating myself. So a ratio is a comparison of one word to another, okay? So that's always the important thing to remember. A ratio, the reason why we're using a ratio is because we want to express a comparison, okay? Comparison of one number to another number, okay? So fractions are helpful in kind of representing that. So if we go back to our shaded or our partly shaded rectangle, okay, there's actually, excuse me, multiple different ratios that we could come up with. And so once again, a ratio is always going to have two parts that we're comparing. And so in this first ratio, 3:7, we're saying, right, in this figure, there are 3 shaded parts to 7 unshaded parts. Okay. Now, like it's saying, this is not a fraction because we're not comparing the part to the whole, the 3 shaded to the whole 10 sections. We're comparing shaded versus unshaded. Okay. And so pretty straightforward. So when you are dealing with ratios, there should always be those two parts and they should have different units. Okay, hopefully you kind of see that, and we'll see that here again. Okay. We could also create a ratio talking about shaded parts to total parts. Okay, and that is a fraction as well, because, right, we're talking about parts of a whole. So we can use the whole or the total as one of our parts in our ratio or part of our ratio relationship. Okay. Or we can, right, create a ratio of unshaded sections to the total amount of sections. We could also, flip this and say 7 unshaded to 3 shaded. Okay. That could also be a ratio. But hopefully you guys are seeing kind of the similarities, but also kind of detecting the differences between them. Okay. So there's 3 different ways that ratios get written in math. Like I said, we're mostly going to be using our fraction form because that's kind of the easiest to do more math with. But if you see a number like this with a colon, once again, it's another way of just representing a ratio. So we would know that whatever we're talking about has a ratio of 7 to 3, which is how you say it, but you could also write it like that with words. Okay. So 3 ways of representing a fraction, or sorry, a ratio. Doing this is something. We're mostly going to be working with ratios expressed as fractions, but like I said, these other are possible. So go ahead and if you look at the bottom of the first page here, please go ahead and write the 4 ratios that they're asking you to write based on the picture right here. Okay. So first you need to do apples to lemons, apples to total fruit, lemons to apples, and then total fruit to lemons. Okay. And once you've gotten those 4 ratios written down, and you can, it's kind of hard on the paper, but hopefully you can see, right, that you can kind of put in the numbers there. So annoyed that this round tool doesn't work. Or you could fill it in here. So it should be the same, but you're either going to use the colon or the words. So hopefully the points, you can kind of see them. I'm going to give you guys a minute or more, and then we'll talk about these. All right, hopefully this is making sense for everyone. So when we create the ratio of apples to lemons, right? We should have written 5:4 or 5:4. And I didn't read this, but I did highlight it just now because I realized I didn't read it, and this is kind of what we saw in that first example where it's a ratio, but not a fraction. And so when we're dealing with ratios, the order in which the numbers appear is very important, okay? And so we can talk about a 7:3 ratio, and we know that that is 7 unshaded to 3 shaded. But we could also, talk about the ratio between shaded to unshaded, and that means we need to put shaded 3 first and unshaded 7 second. So always make sure when you're asked to write a ratio, that you put it in the order that it's given, okay? And so of course, lemons to apples is the opposite, right? So 4 lemons to every 5 apples, okay? If we do apples to total fruit, right, that's a 5:9 ratio. Okay, and then if we do total fruit to lemons, then we need 9. Okay, so hopefully that feels good and makes sense. Does anyone have any questions about how I created these ratios? No, it's not too super hard or scary, and so good. It shouldn't be. Thanks, Kayla. Good job. All right. So I think based on what I saw, I think everyone's feeling pretty good. If you want a little bit more practice creating ratios, you can do those exercises at the top of page 2. But we're not gonna, we only got 9 minutes right now. So I would definitely say for homework, if you feel like you need to do some more of this just to get your brain kind of wrapped around this idea of ratio, you can do the 12 problems at the top of page 2. Okay, and this will kind of be the case as we begin to work through our math units. There'll be lots of practice that we might not do in class that I would strongly recommend that you do outside of class, okay? Because once again, math is kind of, it's like exercise for your brain, right? And so you can't run a marathon unless you train, right? And you can't, hopefully, well, you probably won't be super successful on a high stakes math test if you haven't trained for the test. And so doing these practice problems on your own outside of class is going to be a good strategy And all of the answers are at the end of each unit, so you are definitely gonna be able to look up your answers and confirm, which is of course another huge part of practice. And sometimes I'm not the best at remembering to include the answers, so woohoo! I included the answers. All right. So one of the things that we need to, be aware of is that because because ratios are kind of like fractions, or we can represent ratios as fractions, they do follow some of the same rules as fractions. And so simplifying is going to be one of those characteristics. So like fractions, ratios must be simplified to lowest terms. Okay. And so if we think back about our answers here, 5 and 4, 5 and 9, those are all lowest terms. We couldn't reduce those. So for example, a ratio of 2 to 4 should be written as 1 to 2 or 1 over 2. Okay, right? So we would simplify the ratio just like we would simplify a fraction. We look at both of our numbers and say, is there a common number that we can Celeste, I'm not sure which, oh, you need the link to the materials? Is what I'm guessing from your messaging. Thank you. Okay, no worries. Thank you. Okay. So once again, a ratio is never written as a whole number, right? It should always have those two parts, okay? And so, for example, the ratio 6 to 3 is written as 2 over 1, or sorry, 2 to 1, or 2 over 1. And of course, if this was a fraction, we would say, oh, 2 over 1 is the same as 2. But if we're talking about a ratio, we need both of those pieces, okay? Doing all right there? Let's the chair or the.
I get it.
Hooray! That's always exciting to you. Okay, so that's one of the biggest kind of distinctions that we would make between what is clearly a ratio versus we're treating this like a fraction. Okay, so simplify your ratios. Okay. And of course, so for example, let's see. Try to find one that's, so like if we were gonna do dollar signs to flowers, what would be our ratio of dollar signs to flowers? Oh yeah, sorry, darn it. I was looking for, how about dollar signs and unshaded triangles? 4 to 4. And so what would a 4 over 4, how would that read? Would that need to be simplified if we have 4 over 4? It's actually going to be 1 over 1, right? Because I can divide a 4 out of the top and the bottom. So we'd say it's a 1-to-1 ratio. Okay. And it's not, any fraction where we have two numbers on top is going to be equal to 1. As a ratio, it's going to be a 1-to-1 ratio. For every one of the dollar signs, there's one unshaded triangle. Okay, so hopefully that simplifying step helps and makes sense. And it'll become more apparent because as we begin to look at rates, which is one of the most common ways that we use ratios, generally we're going to have a denominator of 1. Okay, if you think about this, like how we measure our car's speed, right? Miles per hour. So that means we have a ratio of miles to hours, right? We have a ratio of distance to time. And so oftentimes, right, if we're driving 55 miles an hour, that means, right, for every 55 miles of distance, right, should take 1 hour of time. And so hopefully you're beginning to see that relationship. Okay. I think this is a good place to stop, so we'll hop right back into our lesson on Wednesday. So once again, if you can hopefully get the materials or let me know that I need to send you a hard copy, that would be great. And so Art, we'll check in tomorrow, and if they didn't have them in page, I will mail one to you. But thank you for checking up there first, and things might be a little easier. But good work tonight, guys. Hopefully this is feeling okay, and, okay, Celeste, I will send it to you. And so, yeah. Any final questions or concerns? Tomorrow at 6, we'll have language arts class, so hopefully I'll see most of you guys back again. And yeah. Good job, good class. Take care. Go have some dinner. Yes, Victoria, I will mail you and Celeste a copy. Yeah.
But
And Julie, I just have one more question. On Wednesday, we can go to that class next week to work on social studies if we needed.